Hello everyone. So in this video we're going to take up the organic nomenclature exercise worksheet that you can find on our Google Drive. If you haven't already watched all of the organic nomenclature videos in the lecture series, I strongly suggest you go and do that first and then come back to this exercise. Because really none of this will make any sense until you've heard all of the rules for each of the types of compounds that we're going to be talking about. Okay, so in this exercise, we're really driving at naming the molecule and kind of daisy chaining your way there. So we want to number the parent chain, circle all side groups, and name all functional groups as well as the entire molecule. We don't necessarily have to do that in that order. Sometimes it's going to make sense to say find the functional groups first and then number the parent chain because the numbers on the carbons are going to depend on where the functional group is. Okay. So let's get started with this first one here. So here's an example where we might want to first identify which functional group is going to take the priority. So we've got some halides here. There's a double bonded carbon as well as a double bonded oxygen. So going through, we can see that the ketone is going to take the priority in terms of which is going to be the most important functional group. So this is going to give us the O-N-E suffix on the whole molecule. Okay, and that's also going to take the lowest number when we go to number our carbons. So we might as well start numbering our parent chain from the side closest to the ketone. So 1, 2, 3, 4, 5, 6, and now to get to whichever one of these, it actually doesn't matter. So we could pick any one because they're all the same length, so 7. So we know that we're going to have a hept is going to be in the root somewhere, so we might as well write that because it's 7 carbons. And it's going to end with an O-N-E, but we'll just wave that off for a minute. Okay, so let's look at the side groups. So we have chlorine and a chlorine, as well as 2 methyl side groups. Okay. So this would be, now we can number those properly. So we can write 4, 5 dichloro. And we also have 6, 6 dimethyl. Okay, because we have the 2 of those next to each other, 2 of each, right? So they both get to have the di in front of them. Okay, so those are our side groups, and we still haven't talked about this double bonded carbon in the middle here. So that is going to be an ene, and how we're going to stack those up is we have to define which carbon it's onto. So we'll write it's going to be a hept 4-ene. And now we can write out our last suffix, so 2-one. So we have 7 carbons on the parent chain with a double bond on the 4th carbon and a ketone on the 2nd carbon. Okay, and so now what about these side groups? How are we going to put those in front? So we do those alphabetically by the group itself. We can ignore the di part and just look at the chloro or the methyl. So because the chloro is just earlier in the alphabet, it will go first, and we'll have the dimethyl behind it. Move this. I think I've dropped a piece of that, so try it again. Okay. So 4,5 dichloro, 6,6 dimethyl, hept 4-ene 2-one, and we're still missing one part because on this double bond, these are flat to each other, right? So these are both sp2 carbons, and if we put the 2 chlorines on the same side of that double bond, it would be a different molecule than as they are on different sides of this double bond. And so Oops, let's erase that. When we've talked about this, this is going to be the cis or trans isomerism. And which one gets the priority here is the chlorine, because it's a more reactive group than these alkane groups. Okay, so we would say that these chlorines are trans to each other. So the whole thing we would say is trans 4,5-dichloro 6,6-dimethyl heptforene 2-O. Okay, and that would be the full answer that we would expect to see for that molecule. Okay, and admittedly, that's a tough one that we started on. That caught up, I think, quite a lot of what we talked about in the nomenclature portion. So we'll carry on. And if you're following along doing this with me, I think it's probably a little bit of a waste. Either try all of these exercises by yourself first and then come back here to correct, or try each one, hit play on that portion of the video, or come back and just watch that portion of the video. But be sure to at least try these by yourself before you check out the answer, okay? Because all of these you're going to say, oh yeah, no, I would have known to put the di in front of the chloro, or number the methyl groups. It's easy, very easy to say, but until you can show it to yourself that that's what you've done, then I think you're better off trying it first. Okay, so let's do the same thing on this guy. So we see a double bonded carbon, so that's going to get, and there's no other functional groups on here, so we're going to have an ene for a suffix. It also takes the lowest number carbon, so the parent chain has to include that double bond, and that has to have the lowest number possible on it. So we can start numbering our parent chain from the side that it's closest to. So 1, 2, 3, 4. And at this branching point, we have to decide which one's going to be the longest chain. So it's tempting, just because we always draw these chains kind of as a horizontal zigzag, to just go 4, 5, 6 and call it a day with these two as side groups. But if we do that, we're ignoring, first of all, that we could go 5, 6 and that's equivalent length, or that we go 5, 6, 7, 8 and find a much longer parent chain. Okay, so this is actually correct. We go 5, 6, 7, 8. To take the longest chain is the parent group, and that makes these two as side chains on the parent chain. Okay, so this would be now an ethyl, because we have 1, 2 carbons attached, and this just has 1 carbon, so this would be a methyl group. And I think we're done. So we have, how are we going to stack these up? Again, it's alphabetically, so the ethyl will come first. So this is going to be a 4-ethyl. 5-methyl, and it's an 8-parent chain, so this would be an octene. And in fact, we don't even need to have a dash on the back of there. Oh, actually we do, excuse me. This would be an oct-2-ene, just so that we really identify where that double bond is. So 4-ethyl, 5-methyl, oct-2-ene, and you should be able to then take that and break it down to reproduce this molecule. And it might not even look the same, because if you were going to look at that and try to draw it, you'd say, okay, the parent chain is 8. So we go 1, 2, 3, 4, 5, 6, 7, 8. There's a double bond on the second one, so we go 1, 2. There's the double bond. On the 4th carbon is going to be an ethyl group, so 1, 2, 3, 4, 1, 2. And on the 5th carbon is a methyl group. Okay, and that's recreating it, and there is no difference between these two molecules. Okay, that's something that if you can't see it, have a look and just think about it for a moment, and how these bonds, remembering that they can rotate, each of them, to produce this molecule equivalently. Okay, I even drew this ethyl group going the same way. If I drew it going the other way, it would be exactly the same, because again, this is just a single carbon-carbon bond, so this extra group is free to rotate around it, okay, as are all of these. That's why we don't talk about cis and trans just on a single bond, because it can rotate around, okay? These two groups could change position, and then we'd be closer to something like that. All right, let's carry on. What have we got? So we see there's an alcohol group, so this hydroxide group is going to make it alcohol, so we give it the suffix OL. Okay, so that's the alcohol. And the parent chain has to give it the lowest number possible. Okay, so we can start numbering over here at the end of that long carbon chain. And actually, there's two ways that we can do it. We can either give it number 1 and say that this is a 1-ethyl as well. But let's just number these guys off. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it'd be a nonane. But really what we want to do is to give that alcohol the lowest possible number that we can. So we're actually going to start right here with a 1, 2, 3, 4, 5, 6, 7. And this will become a heptanol. Let's see if I can write it without. So that is a heptanol with 2 ethyl side groups, so 1 and 2. So this would be a 1,2 diethyl heptanol. Okay, as opposed to, say, making it a, what would this be, a 1, 2, 3, 4. So this would be a 4-ethyl 3-nonanol. We'll write it that way instead, just to make sure that this alcohol gets on the lowest possible carbon. But that's just to say, I guess, that there's a couple of ways that you might see these things, but we'll stick with our rules. Okay. So what do we got now? So it's still just an unsaturated hydrocarbon, so there's no extra functional groups here, just carbon and hydrogens. So we have a triple bonded carbon. So remembering that a triple bond forces carbons to be linear, so it's going to be drawn linear as well. So wherever this begins and ends is also a carbon. So we're going to number that 1, 2, 3, 4. And the longest parent chain is going to continue on this way, 5, 6. Okay. So the unsaturated group here gives it an yne, YNE. And this would be a 2-hexyne or X2-yne is also fine. And we have 2 side groups. These are both methyl groups, so this would be a 4,4 dimethyl. Hex2-yne or 2-hexyne. Okay, and that should be pretty straightforward right at this point. Okay, so let's see something that we haven't before. So now we have a ring structure here. And the rule around that was to put a cyclo as a prefix, but we still want to start with the functional group. So this is, again, a ketone because we have an R group or a carbon chain coming off of both sides of this double bonded carbonyl. So it's still going to get the suffix -one, and the cyclo is going to be in front. And it's still going to matter how many carbons are now in this cycle group. So 1, 2, 3, 4, 5, 6. So this would be a cyclohexone. And we have to also account for these two side groups that are, again, both methyls. So this carbon is going to be number 1, 2, 3, 4. So we have 4, 4 dimethyl cyclohexone. Okay, and I suppose you could put para dimethyl cyclohexone, but it's not really beautiful. So let's just go with numbering it to 4. Okay, hopefully that's clear enough, and we'll keep moving on. Okay, so here we have two substituted halides, so a fluorine and a chlorine. And we also have two methyl groups. So this dimethyl seems to be a series here. Okay, so there's no particular functional group that's going to take dominance. I mean, the halides will over the methyl, but they don't take anything for the suffix. So this is just going to be an ANE in the end as an alkane, but it's a substituted alkane. And we're going to number the parent chain for the longest run that we can of carbons, and also to minimize the numbers of all the side chains. So if we went from, say, the left side to the right, then all of these numbers would be slightly larger than if we go to right to left. So we're going to start 1, 2, 3, 4, 5, 6. So it's a hexane. And now we just want to identify and number all of the side chains. So we have let's just go up by number. We have a 2-fluoro and a 3,3-dimethyl. And for, that's an F. I'm getting ahead of myself. Okay. 4-fluoro. Okay, and which one's going to, how do we order these guys? It's not by number. It's going to be alphabetically. So the last one alphabetically is this methyl group, ignoring the di in front. Okay, so let's take that and we'll pop it in first, or last, I should say. Second last alphabetically will be the fluoro, and I'm going to have to move this whole thing over to make room for the chlorine. So let's do that. And then, okay, so there's our final molecule name. So 2-chloro, 4-fluoro, 3,3-dimethylhexane. Again, following all the rules about like keeping the numbers low, naming all the side chains, putting them in alphabetical order, and ending with a suffix that's just saying that it's just a straight alkane. Okay, here we go again. So there's a double bonded carbon, so this is going to have an ene on the end. Oh, so, tool. Okay, back to draw. So we have an ene. And we want to number the longest parent chain so that that double bond gets the lowest number. So we'll go 1, 2, 3, 4, 5, and 6. So this is a hex 2-ene or 2-hexene. And we have one side group, the methyl group, and it's on carbon number 3, so this will be a 3-methylhexene. But we have to identify whether this methyl group is on the same side as where we started or the different side. And here it can be maybe not obvious. Do we say that these two methyl groups are cis to each other, or do we say that the chain is trans to itself? In this case, and in most cases where we're just competing between alkanes, we're going to take the longer side chain, so the longer chain that comes out of it, or the larger, heavier groups across the double bond, to say whether or not they're cis or trans to each other. Okay, so in this case, the heavier chain is trans to, I guess this is, not I guess, but I'm saying that this methyl group is competing against just a hydrogen. It's not shown, but it's there. So the heavier two groups are going to be this methyl and the rest of the parent chain. So we're going to say that this is a trans 3-methyl hextuene or 3-methyl 2-hexene. Okay, let's keep moving on. The next one we have nitrogen. So we haven't seen that in any of the groups yet. And so that's going to be our functional group on this. And the rule for a nitrogen just bound to other hydrogens, this we just call it an amine on the end. It is an amine. And we're also just going to write the suffix as amine. So now it's how do we get to the rest of that place? So this functional group has to be on the parent chain and have the lowest number. So we can start our numbering there. 1, 2, and then we can just check which one of these is the side group and which one's the parent chain by going 1, 2 or 1, 2, 3. So this is going to be the longer one, 3, 4, 5. So this is a pentamine. Pentamine. There's no reason for the gap. I just missed it. Okay, and that side chain, let's just put that so that it's all one word, just so it can be as clear as possible. Okay, and this is the side chain is an ethyl group, and so this will be 2-ethyl pentamine. And nothing else going on there, so I think we've covered everything off. 2-ethyl pentamine, we're good to go. Okay. The next one, okay, so we have our functional group. Hopefully you can recognize that as a carboxylic acid. Carboxylic acid. And it takes the suffix oic acid. And how are we going to number these? So again, the carbon on the functional group has to take the lowest number and be on the parent chain. So we have 1, 2, and these are the same length, so it doesn't actually matter which way we go. Let's do this way, 3, 4, 5. So erase that. And so now this, we can call it a pentanoic acid. So pentanoic acid with a side group that has 1, 2, 3 carbons on it. So this is going to be a 2-propyl. That's a Y. 2-propyl pentanoic acid. Okay, and again, you might draw this differently. So if you're going to say it's a pent as the root word, so 1, 2, 3, 4, 5, it's a carboxylic acid. So let's draw that on there. And 2-propyl, so 1, 2, 3. This is the same structure as what we have here. No, it isn't, because I drew it on the wrong carbon. Okay, here we go. We'll try that one more time. So this is carbon 1, so the eraser tool. Whew. Okay, 1, 2, 3, 4, 5. And on now carbon 2 properly. 1, 2, 3. These are the same. Okay. Very good. Okay, so now we have 2 functional groups, or 2 things that we want to pay attention to here. So we have the alcohol, so this is going to take the priority of having the suffix with the OL. And also we have to have an ene in here somewhere because of the double bond. Again, we want to have, in this case, let's put the double bond on the parent chain, and we'll just keep the numbering low. So we'll have 1, 2, 3, 4, 5, 6, 7, 8. So overall, it's going to be an octanol because we're going to still give this alcohol the suffix, okay? But how are we going to handle all this? We have to have oct in there. The alcohol gets the suffix, so we're just going to write on a 2-ene for all. And what else do we have to write on here? We have to decide whether or not this is a cis or trans double bond. Okay, the methyl versus the hydrogen group on this side, and the rest of this chain versus the hydrogen group on that side. So I think it's relatively obvious here that this is going to be a trans oct 2-ene for all. And that's catching up everything we want to be able to recreate that molecule from the word. Okay, and last one, a lot going on, but still we can just follow the same rules that we always have to identify everything we want to catch in here. So really, these are just substituted halides and also a couple methyl groups attached to side groups. The functional group that's going to take the suffix is the double bond. So ultimately, this is going to be an ene. And we want to number that so that it gets the lowest number. So let's start numbering from that side. 1, 2, 3, 4, 5, 6, 7, 8. So this will be a 2-ene, and in fact an oct 2-ene. And now we just have to decide about these side groups. And it's the same side groups that we did before, so it's going to have the same alphabetical ordering. So we'll start with the chlorine, then the fluorine, then the dimethyl groups. So this will be a, I won't be able to measure this correctly, but let's try it anyways. 5-chloro. This would be a 6-fluoro. And like I thought, I wouldn't be able to get that all in there, but just move this out of the way for a minute. And back to the pen. Okay, for a 5,6 dimethyl. Okay, and now we want that last part. 2-octene or oct-2ene. Okay, and okay, we still haven't identified whether this is cis or trans. The heavier groups are on opposite sides to each other, so the whole thing is a trans 5-chloro, 6-fluoro, 5,6 dimethyl oct-2ene. Okay, and I think that gets us to the end of the exercise. Thank you very much for watching. As usual, if you have any questions, you can always get in touch. Hopefully that gave you a little bit of extra practice with how to deal with the organic nomenclature. If you want more practice before the exam, I'll probably do it anyways. I'll just make up another sheet that has just names, and we'll have to create the structure just from the name. Okay, but that's all for now. So thank you very much, and we will see you next time.